That's me, Oluseyi Olarewaju, and I'm here in New York. It's 5:30 in the morning here now, and yeah, I will just go right into the talk. I'm postdoc researcher at the Department of Theater, Film, Television, and Interactive Media. I'm part of Weaver. Weaver is part of a consortium that we try and build machine learning models for data-driven storytelling for esports. So yeah, that's a quick intro. So just for reference, I'll just doing some quick background and motivation, talk about the questions we asked, the grammar, NLG that we used, some experiments that we did, the results, and our conclusion and some future works that we have in the pipeline. So let's talk esports. So esports basically are video games that are played competitively. In 2019, esports had a viewership of about 450 million people, and it's projected to grow at, the audience is projected to grow at 5% for 15% for the next 5 years. So it's a new industry that it's obviously growing at a very rapid rate. And the thing about esports games is that they are quite competitive, and that's what some people like about it. So esports games, so some surveys have shown that esports games lie above the cognitive threshold between being fun to do and difficult to do at the same time. So there are lots and lots of hidden insights in events that happened during esports games, and this complex events, some researchers present insights that they get from those events in forms of stats, logs, and simple text annotations, and some templates. So and while this might be okay for like advanced experts, viewers or players of esports games, it's a bit daunting for new audiences and new people that are new to the game. For example, when I started working with this lab, I hadn't played any competitive sports before, but when I tried to play it was a different experience. I was just used to playing FIFA and the rest of those easy games. But when I tried this esports competition, I had to encourage myself to carry on. And it said that you need like 100 hours to just get started with Dota. You need to practice for 100 hours. So if you've got the time, you can try playing Dota too. All right. Anyway, so one of the reasons why I got motivated to do this work is because linguistic data, there are ways where you can use them to tell stories, from non-linguistic data. So that was one of my motivations. Also, recent research has shown, that, audience and people, they want to have different experiences when they watch esports. Not everybody wants to be or not everybody can be in the arena where you have a lot of people viewing. Some people would have to be probably, at work and wants to keep up with their esports game, So different esports audience wants different experiences. And I believe text is a way where you can use to communicate what is happening live to people who might not be at the arena at the time the esports is going on. Also, there is also the chance, the possibility of personalizing this text, so for some people that their competence is not yet they're not yet proficient at the game, you can, the way you serve the text to them might be different from how you serve it to someone that is more experienced. Some very experienced people don't even want text at all. They just want you to throw the stats at them. So that's another thing you can do with text. And then so going straight to the questions we asked, we just to guide our experiment. One of the first one is, do esports audience perceive text generated from, grammar that is induced from esports casters commentary as accurate when they are, describing highlight moments? And the other one is, how does this text, do they support understanding of the highlight moments that they are describing? So we just frame those to guide our experiment and our approach. So I'll just quickly talk about some variations of NLG systems and how it's been done in like state of the art, they say. So currently, what is more popular now is the neural text generations, where you feed some examples to a neural network, or you fine tune a pre-trained model to generate the kind of text that you want, So that's one end of it. And usually the limitations of these are that you need very large and massive data sets, training examples, like the recent work in 2019 that tried to evaluate end-to-end natural language generation. They had to get 5,000 instances of their training set, and so that's a very huge number. And then another thing is neural networks are, they call them black box. Sometimes they're difficult to explain what they are doing. Sometimes they hallucinate, especially when you're trying to generate like a block of text and not just sentences. They usually just say things that you can't really trace why they said that. And then lastly, they're computationally expensive. And you need dedicated graphic cards. If you are not a large lab, you probably can do it at a very very convenient way to for yourself. So that's one approach to doing text generation. And the other one is using rule-based. Some people call it template-based, but we have used, some people use grammar-based generation as well, and that's what we tried to use in this study. And what we did was, and because we're trying to use esports casters commentaries, because the comments and utterances that casters make during live broadcast of esports, we thought that that's a very rich, it's very rich in linguistic as a linguistic resource, and we could extract some useful production rules, grammar rules from it. So we transcribed the commentaries using 5 transcribers and sometimes 1 or 2 researchers to just fine-tune those commentaries. And then we used a type of probabilistic context-free grammar to induce the grammar, and then to get the rules, and then we sort of and coded the rules into a surface realizer, which just spits out the text for us. And then so we, after getting the text for the highlight moments in the games that we wanted to test, that we were looking at, we conducted our experiment by recruiting 127 participants from Prolific. We made sure that they were active Dota 2 players. And then we split our survey instrument into 2 parts, and each part sort of addressing one of our questions that I showed earlier. So the first part was the part that addressed, if the text were, if audience perceived the text as accurate. And the second part is the part that we were testing if, the text supports the understanding of what is going on, what the text is trying to describe. And so for the first part, we showed for the first part, participants, we showed this first part, all the 120 participants saw this part, so we showed them a video clip with the Dota 2 highlight moments, and when I say highlight moments, maybe I should just clarify that they are like, usually the game stretches for about 45 minutes and 1 hour sometimes, and sometimes there are just moments where not too many action is going on, but highlight moments are the moments where, the teams are either, in a combat, bashing each other and trying to, increase their win probability. So those are the moments we call highlight moments. So we showed 2 minutes of that kind of moments to the participants, and then we asked them, we use the NLG to generate the text for that highlight moment, and then we ask the participants, questions like, how accurate do you think the text recaps the highlight? And then also how fluent do you think the texts are? Those are the 2 questions we asked for the first part of the survey. And then we used a 5-point Likert scale to get some quantitative data from those questions. And then the second part, where we were testing the utility of the text, we grouped the 27 participants into 3 groups. And then we sort of simulated 3 different scenarios. And one was that they only saw the text of another, this is another highlight moment now. So one group only saw the text, another group only saw the video, and the third group only saw both the video and the text. And like, we're trying to see if the text in any way supports understanding of what is happening. So that's why we split them into these 3 groups to simulate those 3 conditions. And and for example, the group that saw only the text is like, a scenario where the person is not in the arena and is probably at home or at work or in transit, and just wants to keep up with, by getting text of the highlight moment of the game. And yeah, so that's why we kind of split them into 3 groups. And so yes, going to our results, we kind of so for the first part, where we were testing the accuracy, it's also called linguistic quality of the text. You can see the descriptive statistics here, and quite clearly we expected this because we were getting the inputs that was being converted into text was from the game, so we expected it to be somewhat accurate, and that was what this result showed us. You can almost see that we almost didn't get an interquartile range here, because about 65% of the response was that it was very accurate. I think about 22% said it was extremely accurate, and I think 15 or 16% said moderately, and there was no one that said not accurate at all. So this sort of confirmed to us that we were in the right direction. And then the next bit, where we are testing the utility of the text, where we had 3 groups, you could see here the text only, the video only, and then the video and text. So in this group, we were expecting that the group that saw video only would sort of answer the questions. They will have a better recall, because we asked them questions like, who was the first hero to die? Like, can you rank how the heroes died in the highlights? Just recall questions that we expect them to. The more you can answer, seems to be the more you answer, the better you would have understood the what happened in the highlights based on the kind of stimuli you got. So we expected the video to do, better, to score better than the group that saw the video only to score better than the text. But from our factorial design, we couldn't statistically, confirm that. We couldn't statistically validate that, but we could, using, the talkie tests, confirm that the group that had a text and a video scored better than the group that had text only. But we couldn't also validate if they scored better than those that saw video only. So that's I suppose another kind of experiment our future work needs to do. So yes, so just to basically conclude everything, we could see from our test that we could conclude that esports commentaries could be used as viable linguistic resource for generating accurate text, and these texts do support understanding if they are embedded with a video clip to users. And in our future work, we want to explore a variation of this NLG system where we could personalize the text to audiences and to viewers. And then we also want to contribute. There's this debate going on about, is it better to use a machine learning and neural network language generation approach, or to use a rule-based and grammar-based approach? There's a huge debate going on. There's like half of, I would say more than half of the NLP field wants to do machine learning, while another half wants to do, another percentage wants to do rule-based. So what we've done so far puts us in a place where in the end we can compare both and see in terms of resources, in terms of cost, and do another paper on that. So that's one thing we want to do. Another thing that I didn't put here is that in the end we found that because the rules, after we got them after we induced them, it became a little bit more like templates again. So and users and audiences' eyes could see if something starts to look very repetitive. They could tell that this is very, it's template, almost like a template. So we're trying to look for in our future work how to make it, and that's why we wanted to try this machine learning approach as well, how to make lexical choices that are not just static, and they're quite dynamic and can change with time. So yeah, those are the things we have in our pipeline for future work. And yeah, that's the general overview of our work. And I'm happy to thanks for listening, and happy to answer any questions you might have.